we are doing AP review again. This is 2006 AB for response 3. We are given a graph that is these lovely convenient geometric shapes, right? Like they're trapezoids and triangles because it's a bunch of lines. So the graph of the function f is shown here. It's much better on the actual AP problem, but this is my really bad version of it. With 6 line segments, and they do give you the coordinate point values of these different points, but they're exactly what you'd expect. They're integer values. Let g be the function such that g of x equals the integral from 0 to x of f of t dt. So part A asks us to find g of 4, g prime of 4, and g double prime of 4. A thing to be aware of in a problem like this, if you're given a graph where you can conveniently find the area because of geometric shapes like triangles and trapezoids or semicircles or whatever, there's a very good chance that you're going to be asked to integrate this graph, and by integrate I just mean find the area, which is what we're going to have to do for g of 4. However, there's also a really good chance that when you're given a function that is defined by an integral, that you're going to be asked to use the second fundamental theorem of calculus and derive this, which is just going to involve finding essentially slopes of the given graph. So let's go ahead and, you're going to ask to derive, you're probably going to be asked to derive it once, which would just be the y values in the graph, and derive it twice, which would be the slopes of the given graph. So part A. So g of 4 is going to be that area that we should kind of expect when we see a graph that has convenient geometric shapes like lines and semicircles, you're going to have to find the area. It's really likely. So this is saying the area under the curve from 0 to 4, which would be here, right? So I'm pretty sure that that's going to end up being this negative triangle, and I say it's a negative triangle because it's below the axis when I integrate from right to left. Sorry, left to right. Failed kindergarten. It's all good. And then plus this trapezoid shape that you could either treat as a trapezoid, or you could break it down if you like it better into 2 triangles and rectangles. It doesn't matter to me. But it's worth noting that this area is going to be negative because it's below the axis, and this area is going to be positive. To be perfectly honest, you could probably notice that these 2 triangles have the same shape, right? That these 2 triangles would cancel each other out because they're the same exact shape above and below the axis, and then you could just find the remaining area. It doesn't matter to me what you think is the better option. So if you did this, you'd have a 1/2. The base of this triangle is 1, and the height of this triangle is a -2, right? And then you'd have a 1/2. The height of this trapezoid is a 2, and the sum of the 2 bases, this base is 1 unit long because it's from 2 to 3, and this base is 1 to 3 units long, so 1 plus 3. So you're going to end up getting this is a -1 plus a 4, which gives you a 3, right? The AP doesn't actually care how you get there. They're really only going to give you credit for the 3, but it's finding the area of the curve. Okay, so we also want g prime. So if g of x is the integral from 0 to x of f of t dt, then g prime of x is going to be the derivative of that integral from 0 to x of f of t dt, right? And what we know is that derivatives will cancel out the integral, and essentially we get f of x times the derivative of x, which is just a 1, minus f of 0 times the derivative of 0, which is a 0. So essentially this just derives to f of x. So now I know that g prime of 4 is the same as f of 4, which is just the y value on the graph, right? This is the y value on the graph at x equals 4. And if you look at your graph at x equals 4, the y value is a 0. So that's a 0. And again, the AP just wants to see that you know g prime of 4 is a 0. And then the last one, if we derive again, g double prime of x should be f prime of x, which is the slope of the given graph, right? So that's the derivative. So slope of the given graph, right? So that means that g double prime of 4 is going to be the slope of the graph at 4. Well, if you notice at 4, the graph is conveniently this line that has a rise of -2 and a run of a +1. So that's a -2/1, or just a -2. And again, the AP is just going to give you credit for those 3 quantities. So that's 3 points, and they just want to see that you did it. Part B, does G have a relative max, min, or neither at 1 justify your answer? Okay, so part B. Remember, we're asking about G, right? So part B, we want to know if is G of 1 a max, a min, or neither, right? Well, if we want to know that information about g of 1, we need to use essentially a g prime sign chart, right? So we're looking specifically here at 1, right? So we want to use a G prime sign chart, right? So G prime of 1 is the same as just F of 1, which is totally 0, right? So what that tells us is that G is level, right? Like, and by level, I mean it has a horizontal tangent line at x equals 1, right? So what'll answer the question about max, min, or neither is whether we are going from increasing to decreasing, which would be a max, decreasing to increasing, which would be a min, or if we're in one of those saddle situations where we either go from increasing to increasing again or decreasing to decreasing again, right? So essentially, I just need to know about the signs of my G prime before and after that. So G prime of x is the slope, right? So G prime is the slope of G, but it's the actual y value of the curve, right? So what I want you to notice is right here, right, before x equals 0, right, to this side, f of x is less than 0, right? Meaning G prime of x is less than 0, meaning G is decreasing. So G looks like this, right? After x equals, sorry, I didn't mean x equals 0, I meant x equals 1, my bad. After x equals 1, right, so after f of x is greater than 0, which means G prime of x is greater than 0, which means G is increasing like this. So what we're looking at is we're looking at a min, because G has a horizontal tangent, it's level at x equals 1, right? And again, you could make this in a sign chart in a bunch of different ways. Essentially, what the AP wanted was they wanted that it's a min, and they wanted your justification in some way. Cool. All right. Part C. Suppose that f is defined for all real numbers x as periodic with a period length of 5, meaning that it does the same thing every 5 units, right, forever. The graph above shows 2 full periods of f. Given that g of 5 is 2, find g of 10 and write an equation for the tangent line for g at 108. So we're asked to do 2 things, right? So here's the thing. The easy way to think about this, right? So we know, like, the easy way to think about this is what's the net change in one period? Right? So the net change in one period, because it's going to do the same thing every time, right? This negative triangle is going to cancel out this triangle, and this positive triangle is going to cancel out this negative triangle. So in one period, the net change is essentially a +2, because this is a rectangle that is 1 unit wide and 2 units tall. So essentially, the net change from one period is a +2, right? So every 5 units, right? So the net change in one period, which is 5x units, right? Every 5x units, this thing should gain a +2 in value, right? Because again, we're finding the area, right? Now they gave us that g of 5, right? G of 5 was a 2. Yeah, g of 5 is a 2. So g of 10, right, should be whatever the g of 5 value is plus 1 full period of area, right? Well, we established that 1 full period of area, right, like 1 full cycle of this thing adds 2. So g of 10 should be a 2 plus a 2, which is a 4. So that's the first thing they ask us to do. Now, the second thing's slightly harder. The second thing, they want us to find the tangent line at 108. So that's the first skill, right? So here's the problem with the second skill. The second skill requires 2 things, right? So the second skill asks you for the equation of a tangent line, okay, tangent line at 108, like at x equals 108. So remember, anytime you want an equation of a line, you need 2 things. Number 1, you need a point, right, which is going to be 108, comma, whatever g of 108 is, which we don't know right now, but we'll figure out. And the second thing you need is a slope, which is going to be g prime of 108, which, if you remember, is the same as f of 108, right? We've already established the relationship that g prime was the same as f. So I need to find these 2 values, right? In order to do this problem, I need to find g of 108, and I need to find f of 108. Cool. So let's think about where 108 lives. So I need to look at the nearest multiple of 5. So I can get g of 105 easily using periods, right, using the period of a function, right, because we've said the period's every 5, right, I picked 105 because I know the value of g of, let's say, 5, or g of 10, it doesn't matter which one you pick, right? I know that g of 10 was a 4, right? I can figure out how many periods I need to go to get to 110 from g of 10. So here's my argument. My argument is that g of 108 is the same as the integral from, well, I can either do, that's an interesting option. I wouldn't have done that. I'm going to go from 10, because I know g of 10, to 105, right, of f of t dt. It's not the way the AP did it. They chose to start at 0, which is a choice, and that's totally up to them. Oh, I see why. So another way to logically get here is to recognize that however many periods you have is worth 2. So g of 10 would have been 2 periods from 0, right? And so we know this period added 2, so this must have been 0, and then the plus 2 got you to g of 5, which is 2, and then the next period added 2. So their argument, when they did the first part of part C, was that g of, that essentially double g of 5 is what would happen, because you had a value for g of 5 and then you doubled it, and that's fine. So so the reason the AP started at 0 is their argument was that you can tell that there are 21 periods, because just like there were 2 periods at 10, right? The reason that there were 2 periods at 10 is 10 was the amount and 5 was per period. So there were 2 full periods to get to 10, which is how they got 2. Their argument, the AP started from 0 to 105, which is fine. It's not the way I would have done it. But the reason they did that is because their argument is you can tell that that's 21 full periods. So that's fine. And then here's the trick. I mentioned going to 105, and then what you're going to want to do is integrate from the 105 to the 108, because that's the weird space that's left, right? So this you can do by periods and say, oh, this is 21 of those full periods, and each period was worth 2, right? And then you'd find the interval from 105 to 108 essentially by looking at the image and recognizing that you're starting at this chunk that's down here, right? So this would be 105 to 106, 106 to 107, and then 107 to 108. So it turns out that you're also going to net another 2 anyway, because it's going to end up being, these guys cancel, right? And this would have been 108. 108 just doesn't have the last 2 triangles. So you end up getting, this is a 42 plus a 2, which gives you 44. Okay, so now we have the first part of the information. We know that my point is 108, 44, and that's fine. But then you also need to find your slope, right? So in order to find your slope, you want f of 108. Well, if you look at this picture, 108 is right here. That's this spot on the original graph because it's periodic, so that's a 2. So f of 108 is a 2. Once you know f of 108 is a 2, you now know the other piece of information you need, which is your slope. So your answer is y minus the y value equals m, my slope, which is 2, x minus the x value, which is a 108. Now, if they had asked you to solve for y, you would have to do so, but they didn't, so that's okay as your answer. If you do want to solve for y, just to be extra safe, just add the 44 over, plus the 2 times the quantity x minus 108. Don't bother to distribute or clean it up, because that's a bad idea in case you do something wrong.